This is SciBite, episode 134 for June 24th, 2014. Hi, everyone, and welcome back to SciBite, Jupiter Broadcasting's weekly science podcast, live on a Tuesday and fresh on a Wednesday over at jupiterbroadcasting.com. My name is Chris, and joining us every single week is our host, Heather. Hey there, Heather.
Hey there, Chris.
Hey, Heather, happy science to you.
Happy science.
So what are we going to talk about today?
Today, we're going to take a look at a theory-breaking exoplanet, a theory-confirming star, Saturn's moon Titan, lunar formation theories, story and spacecraft updates, curiosity news, and as always, take a peek back into history and up in the sky this week.
Holy moly, Heather. Well, I have a suggestion. I'm just going to put it out there. Why don't we kick it off with the news? All right, Heather, what is our first news story tonight?
As is often happening recently, astronomers have once again announced that they've discovered a new type of planet that breaks formation theories. This one is a rocky world weighing 17 times as much of the Earth.
Whoa, that's a big planet.
Yes, past theories have stated that such a large world, rocky world, could not be formed because anything that big would grab a whole bunch of hydrogen gas and would grow to be a Jupiter-like gas giant planet. This one, however, is not. It is just a big, rocky super-Earth.
Okay.
Well, or they're calling now a mega-Earth.
I like that. I like Mega Earth. That's
Mega
good.
Earth.
Mega.
Yes. So this particular one is located about 560 light years away. Its orbit is only about 45 days. Now, it actually also has three other Earth mass planets, what they're calling lava worlds, that are orbiting really close to their star with an orbit of about 20 hours.
Okay.
So pretty much balls of lava swirling around the star.
Ooh.
Now, this was another one that is data from the Kepler Space Telescope.
Right.
Even though it has moved on to a sort of secondary motion of its phase, we're still getting a lot of data out of the primary mission. And they were able to, this is the mission where they calculate a tiny dimming of a star to say, hey, there's a planet passing in front of that star. Notice a couple times, hey, there's probably a planet there. Now, it can't tell anything about it, or much about it. They can't tell whether it's a rocky planet or a gas planet, but they can kind of get an idea of the diameter. And so they were kind of saying, all right, this is roughly the diameter we think it is, so it's probably like a mini Neptune.
Okay.
So then you go to Earthbound telescopes. Then they go back and they kind of pick out some that look interesting, and then they'll go and they'll try to analyze it more closely. Then you can take and they can look at the wobble of a star. Because if a planet orbits it, it'll make the star move just barely, and they can actually measure that from Earth. And this time they actually showed that it weighed 17 times the amount of Earth.
That's nuts.
And it was definitely far more than expected. So it was, with the diameter that they had seen, it had to have been very dense. It had to have been rocks and other, solid material. And, if it ever had an atmosphere, it's so massive, it would still have it. So if it ever had one, it would still have it. And it's not a gas giant. So they're trying to figure out what exactly would cause this. As is usual, every once in a while now, we see a planet, we're like, this is how the planets form. And then we find an exoplanet, we're like, except for that one. Okay, now we think this is how they form. And a couple months later, except for that one. This is once again where we can't really explain such a large rocky world. And not only that, but the system itself is so old. It happened less than 3 billion years after the Big Bang. Now that is actually when the universe was really, really young. Now at the very beginning of the universe, all you had was hydrogen and helium. all the heavier elements that we're made of and that we see, that make up us, and everything else is from when a star goes supernova. It causes heavier elements to occur.
Sure.
Now, scientists really didn't think there would have been enough of those heavier elements to make those rocky world at that time in the universe's history. That should have taken billions of years. But we're obviously seeing something that could say that such huge rocks could have actually formed at that point.
Right.
When heavy elements would have been really scarce, actually. So rocky planets could have formed much earlier than we thought.
So what you're saying is there could be some civilizations out there that have a huge head start on us.
What I'm saying is that they can't. Science looks peculiar at you, skeptically.
I'm just saying that's the inevitable result of what you're saying here, Heather.
Well, it does mean that we can't rule out older stars. I mean, up until recently, it said like,
oh yeah,
okay,
right,
so
right.
We can't look at stars older than this, so we don't have to worry about any of them. We can ignore them.
Right.
And look at this age of stars.
Right.
Now we have to stop and go, well, actually, turn head and look at those stars. Now we do need to look at that data.
So there could be a whole bunch out there we were never even looking at. Interesting.
Yes, so, but yeah, chat room, there's no way to explain everything, no. But scientists want to...
Keep trying. I mean,
they want to keep trying. We really want to keep trying.
Yeah.
You see something, you're like, how did that happen? Let's find out. And then you try to explain it, and then exoplanet formation theories change because we find new things that say, nope, we only thought we had it right.
Right. Well, and that's kind of one of the fun things about following it, in a sense. It really is. Like, that's kind of the more actually kind of exciting aspect of it. And then seeing how it all kind of comes together in the end. Very cool. All right, Heather, well, why don't we, I don't know, take a quick moment, just maybe a pause, if you will. And I want to mention patreon.com/today. We're doing a funding drive over on this. This is tied in with the new Tech Talk Today show that we have. And this is an effort to fund the network from the crowd so that way we can avoid additional advertisers. And we're trying to reach new plateaus. We have a milestone we're trying to get to. It's our next milestone where we'll then have a budget line where we can hire some contractors and get some work done that we need done. It's not just like computer stuff. It's also some facilities things and stuff that we know that we can afford once we have a certain level of funding. And you can help support the Jupiter Broadcasting Network by going to patreon.com/today. That's patreon.com/today. That's our page. You'll find out information about what we're trying to do, the different pledge levels that we suggest, and all of those goodies. This is a way we're trying to raise income without increasing our advertiser load. And as perhaps we'll find the right balance as we kind of see what the response is to this. We may change the advertising up or down, kind of depending on the response we see here. It's all kind of in flux, but the idea is to create a new stable way to keep some money coming to the studio so we can make investments throughout the rest of the year to really get. I want to say to a new plateau. I don't know if that's the right terminology, but that's really what we're trying to get to is the next level, and you guys can help us do it by going to patreon.com/today. Help us out. All right, Heather, why don't we do, I don't know, perhaps another suggestion, the News Bite? Okay, Heather, where are we going to start in the News Bite?
So we broke theories before, but now we are confirming theories.
Okay.
There are actually a star that was theorized that was sort of two stars in one. The theory was that a binary star system where a super-dense neutron star could be absorbed by a less dense red supergiant star.
All right.
Now, this theory was back in 1975. Now, it's very hard to see in real life just because it looks like a red supergiant. In order to really prove it, you have to have detailed spectrographic analysis for the particular chemical signature of a star. Now, because normal red supergiants derive their energy from nuclear fusion. Now, these specific Thorn Zeitkau objects, TOs, are powered by the unusual activity from the neutron star in their core.
Oh.
So the spectrographic analysis would be very different. So astronomers were examining the spectrum of light emitted from what looked like red supergiants. We can tell them what elements are present in the star. Now, when examining the spectrum of one specific star they were analyzing, the scientists actually saw some very strange readings. They were able to take a look at some of the lines in the spectrum and find that it had things like rubidium, lithium, molybdenum. Now, these type of things are elements that are not in red supergiants, but they would be more like from neutron stars.
Uh-huh.
So it would be a unique signature of these type of theorized stars.
Okay.
So it's one of those things where everything looks the same, but you have to kind of look at each red supergiant and take the analysis of every one to see if something happens to look like it.
Okay.
So the idea is that you have two massive stars, a red supergiant and a neutron star, which is a star formed after a supernova. So you have this dense star that can happen after a supernova can leave this behind. So you have these two in a close binary system. And then the more massive red supergiant would essentially swallow up the neutron star, which would spiral down to the core of it. And then that would become the energy source of the red giant. Now, then that would change all the chemical characteristics of the star because there is a lot of different and strange chemistry going on there then. And so there are, from what we see, there are definitely inconsistencies into what some of the details of what the theory would predicted. But the theories are from 1975 as well. There have been a lot of improvements in the theory since then.
Mm-hmm.
They're still tweaking the theory now that they've actually found one. But looking at this can kind of tell us more about this star, more about how stars kind of work internally still, like looking back at different stars. So you say, all right, well, this is kind of how this one is reacting inside of itself. The internal...
Sort of how the plumbing, I mean, it's almost like...
Yeah, exactly.
You get insights into the internals of a star in a very fascinating way.
Yes, in a strange situation. And from that, you can kind of infer and say, well, in this strange case, this is what's going on. Perhaps in a more normalized situation, then this more straightforward approach would be okay.
This is a little star magic right there, really. So it's like so it swallows up a whole other star and then sucks its power.
Yes, but it starts running on the battery power of its old partner.
Yeah.
Somebody in the chat room called it a vampire star.
That's what I was gonna say. It's a vampire star, or like an energy vampire, I suppose.
Yes.
All right. Any other thoughts on that one?
No, just kind of interesting how sometimes we can actually prove theories instead of breaking them.
Hey, yeah, a little from column A, a little from column B. All right, Heather, we'll get ready. The band's here, and that means it's time for the 2-Byte News. All right, Heather, what are we talking about in the 2-Byte News?
Alrighty. The cameras on NASA's spacecraft orbiting, the Cassini spacecraft orbiting Saturn's moon Titan that have been watching some of the large methane lakes are starting to look for waves.
Waves on Saturn?
Yes, there's the methane lakes. And so they're very carefully analyzing some really high detail scans to see, can they spot waves? Now, what they can do is they found patterns in the sunlight reflecting off of one of the northern lakes that could be interpreted as just like 2-centimeter high waves. Now, it could just be a mud flat.
Okay.
Or instead of like a deep lake that could have a shallow film of liquid on top.
Okay.
But if it could be waves, the whole point is no, not surfing chat room. It would confirm that the lake would be deep enough
Oh, right.
to have reservoirs of methane and ethane.
Of course.
And if life, little squirmy life existed on Titan, the best place to look would be in large bodies of liquid, the kind that would form waves.
I guess what I'm hung up on here is that we live in a world where we can observe waves on Saturn.
On Saturn's moons?
Yeah,
We're trying to watch them.
The distance of Saturn. Yeah, I mean, we're trying to at least. We think we see something which is absolutely incredible if you think about it. That's really quite amazing. And so, if there's waves, ergo water's deep enough, ergo it's possible something might be swimming in there.
Ergo, it would be a good place to send a robotic spacecraft mission.
Right. I like the way you think, Heather. Well, while we're doing some thinking, something that has always stumped me is just how did that moon form? Do we have a new theory?
No, we're looking at old theories and kind of confirming them.
Okay.
So according to one formation theory, billions of years ago, we have Mars-sized body of, planet they call Theia. Smashes into Earth. Earth survives, fragments of the crash and parts of Earth all coalesce into the moon. One of the problems has been no evidence of that said planet Theia. Now they believe they may have actually found traces of it in lunar rocks taken from Apollo missions. So before you have oxygen isotopes, before the resolution of microscopes, we couldn't see any significant difference in these isotopes or types of oxygen between any of the lunar samples brought back from the moon and Earth. Now, these type of oxygen isotopes are very distinctive, almost fingerprints for planets, for various bodies of rocks. So we can identify pretty closely and say, hey, this is from here, this is from there. Now, this new research has actually been able to go back through those old rock samples from Apollo and say, we actually think we have, some of these moon rocks have parts per million of this different type of oxygen isotope. They're very small and slightly more difficult to detect. However, they are there. So now it kind of says, wow, we actually do see this. It's much more likely that this type of event happened.
I guess what I'm hung up on is the theory then that the object that smashed into the Earth was absolutely and totally demolished and just absorbed into our rock and the moon's rock, and it didn't break? Like, there's no piece of it that survived and it's out there floating?
The theory would be no.
Okay, so the
theory would be, it smashes into the Earth. Some of that would be that the dense material from the core of that then kind of spreads across the surface of the Earth. It gives us a whole bunch of the great
pieces of evidence, if you will.
Well, minerals and heavy elements that we can use and are very useful on the surface of the Earth.
Right, very much so.
Amazingly enough.
Yeah.
And
quite convenient.
Then part of the Earth and part of the lighter material from that kind of all float off and would have formed the moon. And somebody in the chat room asks about Mars's moons. But in that case, that's the other type of moon formation would be they aren't formed, they're captured. So in that case, it would be asteroids captured, which was one of the theories. Could Earth have captured something the size of the moon? But no, not the size distribution. But in this case, it was the theory, how to calculate that and seeing that, wow, the moon is moving out centimeters by centimeters every so many years. And so going backwards, hey, it says moon would have started at Earth. So then they started this theory and, hey, let's look at the science and the math. And we're actually starting to go further and further along and saying there's more evidence that just the right, statement of events happened.
Right. Oh, thank you. Heather, this just in from the news floor. We got an update, don't we?
We do. On Sci-Fi 130, back in May, we talked about an asteroid-turning comet. This is astronomers with the Catalina Sky Survey picked up a very faint asteroid in a orbit that's more like a comet than an asteroid. Now, these are specific asteroids known as democloids, thought to be various inactive varieties of comet nuclei. So these are sort of thought that these are, comets that have fizzled, they're gone. Now, in May, they saw this asteroid, they happened to spy it, and it gave had a little bit of a fuzz to it. They went, okay, looks like it's starting to activate, like maybe there's something going on. And soon enough, it started having a coma or atmosphere. It's starting to brighten, but get slightly more comet-like looking. So it'll actually reach perihelion just 4 days before its closest approach to Earth. So in early July, it's actually going to be some good binocular viewing or telescope viewing.
Okay.
Not necessarily by eye. It's going to be binocular telescope object.
Yeah, okay.
Now, this thing is going to be trucking. This comet is going to move about 7 degrees. That's the span of the full moon once every hour and 42 minutes.
Okay.
So if you have a telescope pointed at it, you would actually be able to see it moving across the stars field. This is actually something you would be able to see moving in real time if you were able to sit there and just look at it for a minute.
It'd be like a spaceship, only a rock.
Yes, only a rock. Yeah. Only icy kind of rock.
Right. So not like a spaceship at all, but like a spaceship in that it is moving.
Kind of.
Yeah.
In that it's moving.
Yeah.
In that sense, we're all spaceships. And the fact that we move.
Isn't that true, Heather? And speaking of spaceships, hey, come on in, guys. You're cleared for landing. Come on in. Let's go. That's right. We've got a spacecraft update, don't we?
That's right. It is a favorite of mine watching this. This is kind of going on over time. This is the ISEE-3 reboot project. This is one of those where it's an old NASA spacecraft launched way back when NASA had put it to bed. They went, okay,
right,
good job, guys. Good night.
And then they took over like an old McDonald's, right? Set up mission
then
control.
Then they went, oh, wait, it's still awake.
Yeah.
Then they have a group of people who kickstarted a project, and everyone backed them up and said, all right, you have the money. Then they took mission control on an old McDonald's, set up shop. And so they're actually starting to kind of go through, and they've actually started firing some of its thrusters to spin it back up to optimum spin rates so they can fire its rockets to get it into a better orbit. They're starting to kind of look at some of the old scientific data coming back. So they'd seen that almost all of the instruments were still working, not necessarily functioning normally, they're seeming. So they're trying to see, kind of get the raw data that's actually spitting back out, and then going back to the old data that was there, kind of conferring and looking at the old, talking to the old engineers that were on the project, and kind of everybody getting together at a table and scratching it out and going, okay, well, what can we make of this? What kind of data is it actually sending back? What can we make sense of this? And so we're able to kind of get back some stuff.
It looks like they're using some open source software too. GNU
they
Radio.
Are. Yes, they are actually using open source, which means that they're actually kind of able to go to the community and say, hey, everybody, here's this stuff. They have, access to a number of top people in the community that they can go to and say, hey, help us out with this.
That's amazing.
So it really opens them up to some really good resources.
Wow. That's so cool. It's got a little Linux action show tie-in right there.
Yes, there is that. I saw that and I was like, open source.
Yeah, that's
all
great.
The way.
Wow. That's a really cool project that they're working on. That is one of the neatest things. I mean, it just feels like something from a movie where you'd have a group of people who get together and make contact with an old spaceship using computer parts that they assembled themselves at their own makeshift mission control. I mean, it's almost unbelievable.
Yeah, and it is really one of those things because the hardware to talk to this thing doesn't exist anymore.
Right.
Because it wasn't worth the money to keep it running or to keep it together. So NASA tossed it all out.
Wow.
So they kind of had to cobble things together themselves. And then, some physical stuff, and the rest of it, they're able to write software to say, pretend you're this piece of equipment. And it can pretend.
That's amazing. Amazing.
So, they have time on some big dishes, and they're talking to it, and trying to get the thrusters and going, and trying to get all the science out of it that they can. But that kind of keeps going.
I love it. It's like technology archaeology almost.
Oh yeah.
Huh. And if you guys want to find out more, Heather has more stuff you can read in the show notes. You can also check out, like she said earlier, SciByte 132 and SciByte 133 for additional. It's kind of mind blowing. So if you're not up to date on the topic, it's worth catching up on. Heather, while we're up in space doing the space thing, you want to head over to Mars and maybe do a curiosity update?
Let's go.
And liftoff of the Atlas V with Curiosity.
Oh! We're safe on Mars.
There.
Hey, how is our favorite little rover doing? Not so little. How is our favorite rover doing?
It's continuing its road trip. We're headed towards the Mount Sharp, layered mountain in the middle of this Gale crater. Still got some of its drilled powder sample material that's going to deliver for some analysis. One thing that is exciting, is that it was actually able to observe on June the 3rd, Mercury was transited the sun, so it passed in front of the sun. Now, this was the first transit of the sun by a planet observed from any other planet other than Earth. And it was the first imaging of Mercury at all from Mars. And it was pretty amazing because Mercury only filled about 1/6 of one pixel.
Whoa!
So they could just sort of see some darkening.
Yeah.
Now, this wasn't just a random thing. They knew it was going to happen. They knew the timing.
Yeah.
So they had it pointed there. And, they have this specific camera made to look at the stuff because they have, they're analyzing the atmosphere. They want to analyze some of that's going on to see for, clouds, for the clearness, for dust. So they're able to look at things like this and say, they knew this was coming. They're like, hey, this is a great opportunity. Let's look and watch for this. So then they can go back and through and say, hey, tiny dimming.
That's it.
Yes.
That's it. Well, they know exactly where it's going to be. So
yeah, they know pretty much where it's going to be, pretty much the timing where it's going to be, but they were actually able to see it.
Yeah.
Now, you can actually see Mercury and Venus transits more often from Mars than Earth.
Oh, really?
Just because of the...
atmosphere?
No, just because of the orbits.
Oh, okay.
It has nothing to do with the atmosphere. It's just the orbit geometry.
Huh. So it's a good spot to get a nice picture, turns out.
And it's kind of funny because you see the images, and there's 2 black spots on there. No, that's not Mercury. Those are sunspots.
Sunspots. Yeah.
Which are way bigger.
Than Mercury.
They're very, they're slow moving, but yes, you kind of see those and you're like, oh wow, Mercury. Nope.
No.
Those are sunspots.
Those are huge.
Teeny, tiny little 1/6 of 1 pixel, slightly darkening pixels. That's Mercury. Now we have some, as far as Mars stuff goes, we have some testing of some new landing equipment.
Oh.
The low density supersonic decelerator. It's this really ambitious kind of laying the groundwork. It does kind of look like a flying saucer.
Doesn't it look like a flying saucer? It does to me.
Well, all of the landings you see, it's those, it has the shell that kind of goes in, and this specific idea is how to slow that down enough.
Okay.
So first, they have an idea to sort of inflate a little kind of a balloon or airbag around the outside of it, because then it makes it a little bit bigger, a little bit larger surface area, means it slows it down just a little bit.
More resistance and whatnot.
Then you can stick out some supersonic parachutes, and it's a whole system that they're kind of going through and testing. So far, their scheduled times and weather have not come together. They've tried multiple times. They're still kind of trying to get everything to going together, but it's some pretty cool stuff that they're hoping to use in the future.
Yeah.
This is kind of for really large scale things, for, even bigger rovers or human scale, for, if you're going to have human scientific expeditions to come, these are the kind of large scale reentry systems that you would need.
Mm-hmm.
So they're starting to work on that as well. So
That's pretty neat. And you know me, I'm a sucker for anything that's kind of getting science closer to actual sci-fi. It's like my science and my sci-fi come together, and it's like chocolate and peanut butter, Heather. All right. Well, speaking of coming together, why don't we step in the time machine? We got to go back in time. And I don't want to alarm you, Heather, but oh, here we go.
You push the button, then. They don't alarm me.
I don't want to scare you, but I fueled the time machine with bubble gum on accident.
Bubblegum.
Oh, actually, we made it. Oh, it's because they only had to take us 17 years back. Woo! Next week, I promise I will not put bubble gum in the gas tank. So the time machine this week takes us to June 25th, 1997. Like I said, 17 years ago. Heather, what happened this week in science?
The space station Mir had a small accident. It suffered a near fatal mishap when the Progress ferry was being docked via remote control via a cosmonaut. It was accidentally rammed into the science module, put a hole in the pressure vessel, damaged some solar arrays. Useless thereafter. They're able to salvage the station by pretty much severing the electrical and data connections to that part of the station, sealed off that module.
Right.
Lost part of the station, lost about half their electrical power, but they were able to actually save what was left of the station and
absolutely,
be alive.
Well, and
which was what they were kind of going for.
Yeah, I think that's the ultimate goal. Plus, when you zoom out and kind of look down the road, hindsight being 2020, it inspired that realistic and incredible scene in Armageddon, the Bruce Willis thriller where he saves the Earth from an asteroid.
Can you feel the science crying? Is that your protection? So, chat room and listeners, he does this because I don't appreciate that film. Occasionally he brings it up. Randomly. I don't particularly appreciate it. Let's leave it at that. On a positive note, in history, one Martian year ago, Curiosity landed.
Oh, wow.
Now, Martian year is about 686 Earth days.
Okay.
But it's the one Martian year birthday for Curiosity.
Well, happy birthday, Curiosity, Martian style. That's great.
Yes.
All right, well, let me recalibrate the SciByte 2000 so that way we can look up into the sky this week.
All right. As far as the planets go, Mercury is starting to get hidden by the sunrise, so we're not going to be able to see him really much anymore. Venus in the dawn is low in the east. Mars is hanging around at twilight, high in the southwest. We've got the blue-white giant star Spica off to its left. Those are always a nice pair. Blue-white Spica and Mars, nice red and orange pair. Yeah. They're going to be setting in the west about 1 a.m. daylight savings. Jupiter at twilight is low in the west and northwest horizon. It's going to be setting by nightfall. And we've got Saturn over in the evening, over in the southern skies.
Not a bad sky at all. Not bad. And guess what? It's all outlined in the show notes. If you see something in the sky and you're like, I bet that's something I should know. Like, when I look, I wish somebody did this for mountains, because I'll be driving around and be like, I should probably know that mountain name. But now when I look up in the sky, I will have a resource. I'll go over to jupiterbroadcasting.com. I'll click on SciByte 134. I'll scroll down through the chronologically listed show notes that have extra links and multimedia to everything talked about today. And at the bottom of those show notes, I will find the Up in the Sky segment to answer my questions. And Heather, I think that does bring us to the end of this week's episode, doesn't it? Is there anything else?
So.
All right,
Not
very
that I
good.
can think of.
Well, I will leave people with maybe like a pro tip. Like if I was a SciByte listener and I wanted to know the inside trick, here's something I would impart upon you. You can tweet right at Heather. She's JB_Mars_base on Twitter, or you can send us your feedback over to jupiterbroadcasting.com and click the contact link. But if you really want to be a SciByte pro, join us live. We do this show on Tuesdays, jblive.tv, and we'd love to have you show up in our chat room and hang out with us. Heather, thanks for the great show.
Thank you.
And thank you, everyone, for tuning into this week's episode of SciByte. and we'll see you right back here next week.